This has been the saddest winter of my life. I want snow. I look out the window and it looks less like an Antarctic tundra and more like a Beach Boys album cover. Where's the flakes? The snowball fights? The northern lights? And I know, I get it. Seasonal depression, power outages, one wrong step on the ice and you're missing your front teeth. I get it. The snow haters be coming out in droves. But as a Michigander, that's my life. I'll gladly lose teeth if it means more snow. And now the snow is gone. But it wasn't always like this. I think most people tend to understand that Earth's climate tends to fluctuate over long periods of time. Sometimes your dominant species forms economies that depend on making sure the snow never falls again. Or if you've seen the movie Ice Age, you might be aware that sometimes the Earth has ice ages. And those are pretty cold. I like the cold. But what if I told you that Scrat and his nighty hijinks were living in tropical paradise compared to what scientists refer to as Snowball Earth? Around 770 million years ago, fossil evidence suggests that Earth was frozen solid. Completely, like a bomb pop is Puerto Rico compared to how frozen Earth was. Coined Snowball Earth, scientists have debated over how much glaciation took place during that time, as being completely frozen over would seem to make a lot of Earth uninhabitable. However, studying the fossil record for any significant changes to fossil diversity has shown that no mass extinctions or even significant population crashes happened during that time. In fact, studying sedimentary rock formations in China even indicated evidence of photosynthesis during the glaciation. So how did life survive? Various ecosystems have been proposed as thermal refugia, where life could escape the freezing climates and continue living, such as hydrothermal vents, glacial shelves, and marine ecosystems that were providing oxygen by glacial meltwater. Fossils of aquatic bottom dwellers further suggest that open oceans had access to oxygen and may have had cracks or even no ice above them for prolonged intervals. To accommodate this, scientists have posited alternative hypotheses such as slushball Earth that suggest that temperatures were warm enough to form an ice-free equator with ice-free continental shelves and a functional water cycle that would make it more likely for organisms to survive near the equator. Well, what kind of life was there? We still had a few 100 million years before we got the kooky little freaks of the Cambrian explosion. Now, during Snowball Earth, we had small things. Some algae here, some cyanobacteria there, a bunch of stromatolites addicted to smoking oxygen. Actually, in his paper on plant evolution, Jacob Zarsky argues that algae and other land plants may have taken their traits that helped them survive the icy waters of Snowball Earth and co-opted them to adopt to dry land. This is an ancient example of exaptation, which is when a certain trait in a species eventually changes its function during evolution. And that evolution is what we want to study in these organisms and how they adapted to this frozen wasteland, as even places of thermal refugia were likely vulnerable to these extreme conditions. But what kind of organisms would live in such extreme conditions, these extremists? Extremophilic microbes, or extremophiles, serve as nifty little subjects to study how life adapts to drastic environmental change. You can see these guys in the Grand Prismatic Spring in Yellowstone, a hot spring where the razzle-dazzle rainbow ring is caused by bacteria, which will affect light and change colors depending on the concentrations of pigmentation within them. See that yellow? See that yellow color? The water right there is a nice and chilly 75 degrees Celsius, enough to give you a third-degree burn on contact. Yet, these microbes have adapted to these super hot temperatures and are known as thermophiles because they like third-degree burn water. It feels nice to them. Similarly, Spain's Rio Tinto is a river with very high acidity and concentrations of heavy metal, though you won't find any humans here unless they're joining the X-Men. The river was found to be home to microalgae. Fascinatingly, however, genetic ancestry studies found that they were more closely related to neutrophilic algae than acidophiles, suggesting that they were able to rapidly adapt to these extreme conditions despite not being used to acid and metal. It was hypothesized that spontaneous mutations of resistance genes allowed these microalgae to flourish, and further research was conducted to determine if these random mutations would enable microbes to survive Snowball Earth conditions. By incubating microbes in geothermal waters for prolonged periods of time, some microbial populations rebounded after an initial mass die-off. One study analyzed whether gradual adaptation or sudden mutation were the dominant methods of evolving resistance genes to extreme conditions, and sudden mutations were found to fit the norm for microbial adaptations. Cyanobacteria and microalgae were also found to be able to better inhabit stressful environments if they underwent locus-bound mutations. So spontaneous mutations were likely a significant contributing factor that helped microbes rapidly adapt to glacial conditions. And this would further allow your microbial organisms to mutate and colonize geothermal waters. We can even zoom in on how this works. The CoRA gene was found to be critical to this adaptation of cells to salty environments by regulating the amount of magnesium present within ancient heterotrophs, which allowed for a more complex response system to things that might stress you out, like the horrors or fluctuating salinity levels. However, at the end of the day, this is science. Despite the evidence of adaptations that organisms made to the ice-cold weather and the associated thermal refuge that enabled the algae to continue floating around talking algae politics and whatnot, there is still significant room for understanding how the fossil record details our knowledge of life during this time period. I mean, I ain't no spring chicken myself, but 7 million years does a lot to a fossil record, and whether we need more fossils to give us better understanding of this period, or if the original Snowball Earth model was just ironically too extreme to be a good model, further research is necessary to truly understand how life survived the Great Refrigeration. Thanks for watching. I'm going to keep wishing for a blizzard now. Maybe Santa Claus will actually give me some this winter. Peace.